Rounding numbers might seem incredibly basic, but examiners use bounds of division to completely trap you and destroy your A-star grade. If you divide an upper bound by another upper bound, you will instantly lose all your accuracy marks on the final exam. Imagine a massive futuristic spaceship preparing to dock with an orbiting space station. The metallic airlock doors must perfectly align to survive. To navigate the vast cosmic distance safely, the computer uses estimation. It rounds the distance numbers to calculate a fast, rough trajectory. But as the spaceship physically enters the tight docking bay, estimation becomes extremely dangerous. The metal hull is built to strict safety tolerances. If the spaceship is built slightly too large and the airlock door is built slightly too small, they will violently crash together. In mathematics, this maximum and minimum physical tolerance is called the upper and lower bounds. Let us start with basic rounding rules. Look at the decimal, 0.006207. The examiner wants it rounded to 3 significant figures safely. Here is a common trap. Leading zeros never count. The first true significant figure is actually the number 6. Remember this perfectly. The 0 trapped between the 6 and the 2 does count. So the third significant figure is exactly the 0 right here. Because the next digit is a 7, we must round up. The final mathematical answer is 0.00621. Next trap. Round 4.998 to exactly 2 decimal places. We carefully look at the third decimal, which is 8. The 8 rounds the 9 up to a 10, making the next 9 a 10, which pushes the 4 up to a 5. A massive 0 mark stamp hits your paper if you just write 5. You must write 5.00 to prove accuracy. Now for estimation, calculate an estimate for 17.3 multiplied by 3.81 divided by exactly 11.5. You must strictly round every single number to exactly 1 significant figure before doing any mathematical calculation on your IGCSE paper. 17.3 safely rounds to 20. 3.81 rounds to exactly 4. 11.5 rounds perfectly to 10. Our new equation is 20 multiplied by 4 divided by 10. 20 times 4 is exactly 80. Write this down on your paper. 80 divided by 10 is perfectly 8. The estimated answer is 8. Now, we enter the most dangerous bounds calculations immediately. A number x rounded to the nearest 100 is 24,800. We must mathematically construct the error interval. Step 1. Take the stated degree of accuracy, which is 100, and divide it strictly by 2. This gives us exactly 50. Add 50 to find the upper bound, 24,850. This is the absolute maximum mathematical limit safely. Subtract 50 to find the lower bound, 24,750. Now write the strict mathematical error interval safely. The lower bound uses a less than or equal to sign. The upper bound uses a strictly less than sign. Always verify this perfectly. The interval reads 24,750 is less than or equal to x, strictly less than 24,850. Now for the final boss, calculations using bounds. If we add a and b, the maximum result simply uses both upper bounds securely. But what if we divide a by b? This is the Spaceship Docking Sequence. We want to mathematically find the absolute maximum upper bound. If you wrongly divide the upper bound of a by the upper bound of b, you trigger the examiner trap perfectly. 0 marks. To make a fraction as massively large as possible, you must divide the upper bound of a by the strict lower bound of b. The largest possible spaceship, squeezing through the absolute smallest possible airlock door. Maximum numerator divided by minimum denominator mathematically equals the absolute upper bound. Let us solve an exam question. A garden path is 6 meters. A fence panel is 0.5 meters exactly. Both measurements are rounded to the nearest 10 centimeters exactly. Find the absolute minimum number of fence panels David needs to safely purchase. To find the absolute minimum result of this division, we must divide the strict lower bound by the absolute upper bound mathematically. We divide the absolute shortest path by the absolute longest fence panel. Minimum distance perfectly divided by the maximum panel length safely. 10 centimeters is 0.1 meters. Divide by 2 to get 0.05. Now construct your two safe mathematical bounds. The lower bound of the garden path is 6 minus 0.05. This is exactly 5.95 meters safely. The upper bound of the fence panel is 0.5 plus 0.05. This is 0.55 meters securely. Divide 5.95 by 0.55 carefully. The mathematical calculation yields 10.818 panels entirely. Since David can only purchase whole panels, we round up safely. David must buy exactly 11 fence panels to complete his garden perfectly. Let us rapidly recap the unbreakable rules. For error intervals, always use the less than or equal to sign for the strict lower bound. Always use the strictly less than sign for the upper bound limit. If the exam asks for 2 decimals, never leave off trailing zeros. To estimate complex calculations, round every single number strictly to one significant figure before multiplying or dividing anything on your exam paper. Finally, for division upper bounds, strictly divide upper by lower. For division lower bounds, safely divide lower by upper. Secure your marks today. Follow GetYourTutors for more Cambridge Math masterclasses and guarantee your perfect A-star grade on your upcoming exam today.